Hi everyone. Today I will talk about some experimental trick for experiment 3 EE281. So let me share my screen. Yeah, you can see the LTspice blank page. So let's look the experiment sheet and go step by step. As you can see, the first circuit is about the Thevenin circuit. I will create a circuit like that, but the values will be different. So please do write this assigning the value of your own simulations. We can start with the components. As I select the component tab, so I'm select to the voltage source for creating my circuit, and one is here and another one is here. So again, I'm looking at circuit. Okay, there's a resistive circuit, so I can put a resistor here and here. I can put here. So I will translate this one here. Sorry. I'm creating the lines, connection lines. So please don't forget adding ground. I'm adding my ground. So you can see my circuit. It's look like this one. So I need measure the Thevenin voltage and current from this node between this node A and B. So for measuring the voltage from this one, also I'm adding this resistor here. So I complete my circuit. So let's assign a values for the example circuit. I'm assigning the 15 volt, the first voltage source, and click OK. So I'm assigning the 100 ohm for this one, and assigning to 1k ohm for this resistor. Another resistor is here, so I'm assigning 250 ohm for this one, and 5 volt for this one. So this is my load resistance. So I want to create the equivalent Thevenin circuit for this complex circuit. So I will cut my load because I want to create the equivalent Thevenin circuit. So I cut my load, and I will give a name for this node with this tab. You can see the label net. I select this one, and I'm writing here A, as you see in the experiment sheet. The name of the node is A. So I'm writing is here A. You can write any name what you want. So according to the experiment sheet, I will name this node as an A. So I select A, and my label is coming. So I'm coming here, the end of this line, and click one time, left click, and it named this node as an A. So again, also I want to another name B, and click OK, and I'm assigned the B. So you can see the B node is actually the ground. So the voltage between A and B also is equal to voltage of A. So I want to measure to voltage of this node. So I'm clicking the run button. So DC, I'm selecting the DC operating point, and you can see there is an explanation here about the capacitance and inductance. So there is no capacitance and inductance in our circuit, so there is no important right now. And I'm clicking the OK button, and it's returns the results for me. Let's look the results. So you can see I'm assigning the name A. So the voltage of A is measured as 6.85 volt, as you can see. And I will take a note here. 6.85 volt. So again, I'm closing this tab. Also, again, run. You can see the another nodes and currents in here. For example, when you come to here, please look at this side. When I come to node, please look at this line, this specific the left down corner of the page. I'm coming here, and you can see the node name from the left side. This is node name is N001. The node name is, you can see the node A. So I assigned this name. As you can see, there is another node here. So this node is named as default N003. As you can see, the node name from here. So, and I want to measure also the short circuit current from between A and B. So I will take another resistors, and I'm putting it here, and I'm assigning a very small resistance here, for example 1 milliohm, and OK. So again, I'm running the simulation. So you can see this is the resistor name is R4, and you can see the current of R4. This is 0.0336 amp. So I'm taking my note again. This is because Thevenin short circuit current. So I obtained the Thevenin voltage and Thevenin short circuit current. So I'm seeing my experiment sheet. So we can obtain the Thevenin voltage and current. So we did this one. We measured the short circuit current. And it says that use transit simulation and measure the between these nodes with load resistance. So I can change my resistance. For example, I want to select 1 kilo ohm is my load resistance. So I will measure the voltage and current flowing through the R4 resistance. So I am deleting my DC analysis, and I'm selecting the transient. So stop time maybe 1 second, 0, and I want to simulation with 0.001 step. Okay. So this is the current flow on the my load resistors, and this is the voltage, the red one. Also, I'm taking my notes for these current and voltage values. The voltage is 5.69 and the current is 5.7 milliamp. Please see the milliamp and voltage. The units is important. So I'm closing my. I will take me here, and I'm closing here, and so I got 4 measurements. The first one is Thevenin voltage. The second one is Thevenin current between the A and B, and also I add a resistance here for 1 k ohm, and I measured using transient analysis the voltage and current on this resistor. So let's continue. Let's create a Thevenin circuit like this. So in the Thevenin circuit, you know, there is a 1 voltage source, there is a Thevenin resistance here, and there is a 1 load here. So I am deleting these ones, this one. So okay, I am completing my circuit. So as you can see, my load is here, and I need my Thevenin resistance. So I taken my notes. I saw my notes. If I divided my Thevenin voltage to my Thevenin current, short circuit current, I will obtain a 200 ohm as my Thevenin resistance. So I am assigning my Thevenin resistance as a 200 ohm, and also my Thevenin voltage is. Please remember, we measured 6.85. So I'm ready for the simulation. That looks the results. Is it correct? So I'm measuring again my load resistance, current, and voltage. As you can see, nearly the same values with the previous circuit. This is the Thevenin circuit. Creates my same results because this is the equivalent circuit of the figure 1 in the experiment sheet. So that's all about the Thevenin circuit. So we create this circuit and we obtain the nearly same results. So we can see this one, northern side. So I'm closing here, and I will create the northern circuit. I'm deleting everything for showing the from 0. And again, I'm looking to circuit. There's a 2 voltage source and there's a 3 resistors here, and I will measure these quantities between A and B. So I'm selecting again voltage source, voltage, okay. One voltage source here, another one here. So the resistance, one resistance here, one resistance here, and one here. So I'm selecting, I'm creating the connections. This one, this one, this one. Okay. I'm adding the ground. So in the Norton circuit, also I am assigning a random values different from your experiment sheets. Please be careful. Don't write in your reports to my random selecting values. Please read your experiment sheet and use the values on the experiment sheet. So I'm assigning here 700 ohm. I am assigning here, for example, 1k ohm. I am assigning here randomly 3.3 k ohm. Okay, and the voltage is 5 volt, and the second voltage is 5 volt. Okay, so we have a node in here A and B. So I am showing this node with an resistance. I'm adding an extra resistor here for measuring the voltage and current between the node A and B. So I'm again assigning the node A, okay, here, and again assigning node B here. As you can see, node B is equal to ground, and node A is here. So I want to measure. I want to measure an current between A and B node. So I can assign to measure current very small resistance. For example, 0.001. Okay. So I can complete my Norton circuit and start the simulation. Transient stop time is 1 second, 0, and maximum step will be 0.001. Okay. So you can see the current flowing here. This is 1k ohm and this is 1 milliohm. So this is very small resistance according to this one. So the effect of this resistance to the current flowing in here is very small. So it can be negligible. I'm taking my notes. The Norton short circuit current is 3.2 milliamp. Please be careful about the unit, milliamp. So I'm closing here, and I want to measure. The voltage from here, because if I have a multimeter, I can measure the equivalent resistance for this circuit. Also, you can calculate the manual with this equivalent resistance for this node. How can calculate? You can see R3 and this R3 are parallel each other, and R1 is series. So in my circuit, this 3.3 kilo ohm and this 700 ohm are parallel each other. So the equivalent resistance will be 577 ohm, and this is series this one. So the equivalent resistance, the Norton resistance between node A and node B is equal to according to my calculation, according to my values, 1.577 kilo ohm. So I can change this value as a 1 million ohm because I want to measure the voltage for this node, and I'm clicking OK. So I can measure the voltage from here, run again, and I see my voltage probe and left click. As you can see, 4.99 volt is my open circuit voltage is here. If I divided this voltage value to my previous current value, that was 3.2 milliamp, so I can obtain the equivalent resistance as I calculated before, just before. So I can obtain my equivalent Norton circuit with these values. So that's all for Norton circuit. So please don't try to create this circuit in the LTspice, because you cannot measure the ohm. There is no any ohm meter in the LTspice. So we will measure the voltage, open circuit voltage, with assigning a very high resistance, because 1 million ohm is very bigger than the 1k ohm. So the voltage will be correct for this measurement. So I will not create Norton equivalent circuit, because I created Thevenin equivalent circuit. It's the same logic. You can create Norton equivalent circuit easily, because we obtain the Norton resistance and Norton current. So you can create this easily. In this video, you learned the DC operating point simulation and transient simulation. Again, you know, previous experiments, we used it. So that's all. Again, I'm warning you, I selected the values for the video randomly, not exact value in your experiment sheet. Please read your experiment sheet and assign the correct values to your circuit, as you can see here. So that's all for today. If you have a question, you can ask via the forum in METU class. We will open a forum to answer your questions. Thank you. I'm stopping my screen sharing. So thank you.